Why have variable displacement piston pumps become the mainstream choice for large hydraulic equipment? In the previous episode, we talked about the key differences between variable displacement pumps and fixed displacement pumps. We learned that fixed displacement pumps provide a stable output, while variable displacement pumps can actively adjust their output flow according to the system's needs. But this raises another question. Are these two types of pumps not enough? Why do large hydraulic systems, especially construction machinery, die casting machines, and injection molding machines, prefer variable displacement piston pumps? What makes them so advantageous? The answer lies in the demands that large-scale equipment places on hydraulic systems. It's not just about having power. It also requires high pressure, high flow, high efficiency, and precise power matching. First, let's look at the key feature of variable displacement piston pumps: high pressure and high flow capacity. In large hydraulic equipment, actuators often require suspensional power. For example, large die casting machines require rapid mold closing. Construction machinery needs to drive heavy load movements. At this point, ordinary small pumps often struggle to meet both requirements: the demands for high pressure and high flow. Variable displacement piston pumps use multiple pistons moving back and forth. They can provide higher pressure ratings while meeting the power requirements of large-scale equipment. Second advantage, it can adjust its output according to changes in the load. Large equipment does not always require maximum power during operation. For example, when the equipment moves quickly, it requires a high flow rate. When maintaining pressure, however, only a small flow rate is required. If a fixed displacement pump is used, even when the system does not need that much hydraulic fluid, the pump continues to deliver it. The excess energy is then converted into heat and losses. The variable displacement piston pump can automatically adjust its displacement according to actual demand. It increases output when more power is needed and reduces output when less is needed. This not only improves efficiency but also reduces energy waste. Third advantage, it is better suited for complex control systems. As we discussed in previous episodes, modern hydraulic systems increasingly rely on proportional valves, servo control, and closed-loop feedback. Variable displacement piston pumps work well with these control components. It can adjust its output in real time according to the system's pressure and flow requirements, allowing the entire hydraulic system to achieve optimal power matching and stable operation. But this raises another question. So, should every piece of equipment use a variable displacement piston pump? The answer is not necessarily. If the equipment has a simple structure with fixed flow requirements and a strong focus on cost, a fixed displacement pump may already be sufficient. If the equipment requires high power output and operates under frequently changing conditions, while also prioritizing efficiency and stability, a variable displacement piston pump is often the more suitable choice. Therefore, variable displacement piston pumps have become a mainstream choice for large hydraulic equipment, not because they are more expensive, but because they can provide the power when it is needed and reduce waste when it is not. In one sentence, a fixed displacement pump provides a stable source of power. A variable displacement piston pump solves the challenge of intelligently matching power output to demand under high load and high efficiency requirements. And hydraulic systems are evolving from simply providing power in the past toward more precise, efficient, and intelligent power control. If you found this helpful, follow for more. In the next episode, we'll dive deeper